Today we're going to discuss how we calculate the atomic number and the atomic mass of an atom. We're also going to look into what type of information we can gather if we know the atomic number and mass of an atom. The atomic number of an atom is pretty simple. You can calculate the atomic number of an atom by simply counting the number of protons. Different elements have different numbers of protons, and as we said in the past, that periodic table organizes the elements starting in the top left-hand corner in order of increasing atomic number. For instance, a hydrogen atom only has one proton, which identifies it as hydrogen, whereas a sodium atom has 11 protons, which tells us that it's sodium. So the number of protons tells us the type of atom it is, and elements are made up of the same types of atoms. So a piece of sodium that we can actually grab is made up of billions of sodium atoms hanging out together. A piece of aluminum would be made up of a bunch of aluminum atoms hanging out together. If you recall, all the elements on the periodic table of elements are in their neutral state. So, with that said, we know that the number of protons is going to equal the number of electrons, because in order to be in a neutral state, your net charge, meaning the overall charge of the atom, has to be 0. So if you have 10 protons that are positively charged, you need to have 10 electrons that are negatively charged. That balances out the positives and negatives, which gives you a net charge of 0. An example of this might be a fluorine atom. So let's look at a fluorine atom. In our fluorine atom here, you'll see that you have 1, 2, 3, 4, 5, 6, 7, 8, 9 protons in the nucleus. Those 9 protons tell us that it's fluorine, and it tells us the atomic number is 9. You'll also notice in the nucleus you have neutrons. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 neutrons as well. The neutrons will factor in a little bit later when we discuss atomic mass. But if we just look at the positive protons, which is our atomic number of 9, and then we count up the number of electrons here, we have 1, 2 electrons in the K shell, and then 1, 2, 3, 4, 5, 6, 7 electrons in the L shell, which is a total of 9 electrons. So you have 9 positive protons and 9 negative electrons. When you count up the total charges, you'll find that the 9 negative electron charges cancel out the 9 positive protons. So you have a net charge of 0. So the overall charge of this atom is neutral. You have no net charge. Just remember that all the atoms on the periodic table are in their neutral state, so that if you know what the atomic number of an atom of a particular element is, you know that that's how many electrons it should have in its electron shells in its neutral state. So just remember that in the neutral state, an atom has equal numbers of protons and electrons. Now that we know how to figure out the atomic number of an atom, let's talk about how we figure out the atomic mass of an atom. In order to calculate the atomic mass of an atom, we need to add up the number of protons in the nucleus plus the number of neutrons in the nucleus. Now, because protons and neutrons and electrons make up atoms, and atoms make up all matter, and matter has mass, that tells us that protons, neutrons, and electrons have mass. So what is the mass of a proton and a neutron? Well, it's so small that we don't measure it in grams. We actually measure it in what we call atomic mass units, or AMUs. A neutron also has a mass of 1 AMU. An electron has an atomic mass that is so small that it doesn't even factor in when we discuss the overall mass of an atom, because it's only about 1/1800th, a little bit more of an atomic mass unit. Let's go look at that fluorine atom again and calculate its atomic mass. Now, we look at this atom and we say, all right, what kind of atom is it? Let's try and figure it out. If we count up all the protons here, we'll find that there's 9 protons. So that tells us we have an atomic number of 9, so it's fluorine. Now let's try to calculate its atomic mass. We calculate atomic mass by adding up the number of protons plus the number of neutrons. And in this particular fluorine atom, we already know that we have 9 protons. So let's count up the number of neutrons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 neutrons. So if we add the protons plus the neutrons, that gives us an atomic mass of 18 AMU. So this particular fluorine atom has an atomic number of 9 because it has 9 protons, and an atomic mass of 18 because it has 9 protons and 9 neutrons. You may notice that on some periodic tables of elements, the atomic mass is in a decimal. This is because most atoms of elements exist in slightly different forms. And what the heck do we mean by that? We mean that some atoms of elements have different numbers of neutrons in them. So we may have a fluorine atom that instead of having 9 neutrons, has 10 neutrons, or 8 neutrons, which won't affect its overall net charge because it still has the 9 protons and 9 electrons, but it will affect its atomic mass. You need to remember that the number of protons of an atom of any specific element never change, but sometimes they will have different numbers of neutrons. When atoms of the same element have different numbers of neutrons, we call that an isotope. Let's go look at some examples of isotopes. Here, we have 3 different isotopes of lithium. I know it's lithium number 1 because of the symbol here, and I know that lithium is on the periodic table and its atomic number is 3, which tells me that it's got 3 protons. So all lithiums have 3 protons. What you should notice is that the masses of each one of these lithium isotopes is different. You should see here that this lithium atom has an atomic number of 6. And if we know it has 3 protons, we can calculate the number of neutrons simply by subtracting the atomic number from the atomic mass. So to calculate the number of neutrons in an atom, you simply subtract the atomic number from the atomic mass. The atomic mass minus the atomic number gives us the number of neutrons. So an isotope of a particular element just simply means that it has the same number of protons but different numbers of neutrons. And if we want to calculate that out, we simply subtract the atomic number from its mass. Okay, here on the right we have the 3 isotopes of hydrogen. Most hydrogen exists with 1 proton and no neutrons. Other isotopes of hydrogen that exist have 1 proton and 1 neutron, or 1 proton and 2 neutrons. But notice the one thing that remains constant and tells us it's hydrogen is the number of protons. Okay? So that's all we have for today. If you have any questions, please feel free to ask.